This is our galaxy, a few 100 billion stars, and this is what we expected to find. Every one of those points, somebody's home, somebody's history, somebody looking back. Because the numbers say they should be there. Hundreds of billions of stars. 13.5 billion years for something to happen on one of them. The Earth is only 4.5 billion years old. The galaxy was already ancient, already spinning, already building worlds for 9 billion years before our planet existed. The galaxy should be crowded. And this is what we actually see. 1. Us. The reason is not the one you're expecting. It isn't that they're hiding. It isn't that they came and left. It's that we have barely started looking. The question has a birthday. Summer, 1950, Los Alamos. A group of physicists walking to lunch, joking about a cartoon in the paper. Flying saucers, stealing city trash cans. The talk drifted to whether anything could really cross between the stars. And partway through the meal, Enrico Fermi looked up and asked, more or less, "Where is everybody?" Nobody at that table could answer him. 75 years later, nobody can. Be honest about what that moment was, though, because it gets dressed up. Fermi wasn't presenting a theory. He was a very smart man doing arithmetic in his head over lunch, and finding the numbers didn't sit right. Here's the sharpened version. Forget warp drives. Imagine a civilization that spreads slowly, a ship crawling to a nearby star, settling, and centuries later sending out its own ships. Slow, patient, nothing magic. Even at that crawl, they'd touch every corner of the galaxy in a few million years. Maybe 100 million, if they were in no hurry at all. The galaxy is 13.5 billion years old. 100 million years against that is an afternoon. Someone should have crossed this galaxy 100 times over by now. So where is everybody? In 1961, an astronomer named Frank Drake sat down to write an agenda. He was hosting the first serious meeting about searching for alien signals, and he wanted to structure the conversation. So he wrote down everything you'd need to know to answer Fermi. How fast do stars form? How many have planets? How many of those planets could hold life? On how many does life actually start? How often does life get complex, then clever? How many clever species build something we could hear? And the last one, the one that ruins everybody's evening, how long does a civilization stay detectable before it goes quiet? Multiply them together, and you get a number. The number of civilizations out there we might hear. Now watch what happens. Choose hopeful values for those terms, all perfectly defensible. And the equation says the galaxy holds millions of civilizations. Choose gloomy values, also perfectly defensible. And the same equation says the number is less than 1, meaning us, meaning nobody else in all that dark. Same equation, same math. A gap of a factor of 1 billion, depending on numbers nobody has ever measured, which sounds like a failure. It isn't. Drake's equation was never a calculator. It's a list of everything we don't know, written out in a tidy row, so we can see exactly how much we don't know. And in 60 years, we've filled in the first 2 or 3 terms properly. The rest are still guesses. But there's a darker way to read that empty sky. In 1996, an economist named Robin Hanson proposed something he called the Great Filter. There's a road that runs from dead chemistry all the way to a civilization among the stars. Dead rock, the first cell, complex cells, animals, intelligence, the stars. If the galaxy is empty, then somewhere on that road is a step almost nothing gets past, a filter. And the only question that matters about our own future is one word: where? Is it behind us? Here's the strangest fact in the history of life on Earth. Life started here fast. Simple cells, up and running, at least 3.5 billion years ago. That part was easy, apparently. And then Earth just sat there. For roughly 2 billion years, this planet was nothing but microbes. No animals, no plants, no plants, just slime, for longer than everything that has happened since. What broke the deadlock was one cell swallowing another, and instead of digesting it, keeping it. The complex cell. Every animal, every tree, every one of us descends from that single event. As far as we can tell, in 4 billion years, it happened once. That's a filter behind us. A hurdle we cleared by an accident so unlikely it may never have happened anywhere else. If that's the answer, we're alone. And we're the lucky ones. But it might not be behind us. It might be ahead. It might be that life is common, and intelligence is common, and keeping a civilization is not. That every species which learns to reshape its world eventually reshapes it into something it can't live on. That the silence isn't emptiness. It's a warning we don't know how to read, which leads somewhere genuinely upsetting by way of the philosopher Nick Bostrom. If we ever drill into the ice of Mars or the ocean of Europa and find life down there, even a smear of microbes, that would be terrible news. Because it would mean life starts easily, which means the filter probably isn't behind us, which means it's still in front. That's a hypothesis, not a discovery. But it's why some scientists quietly hope Mars is dead. The filter isn't the only explanation, and it isn't the most likely one. Maybe we're just early. Stars will keep forming for trillions more years. Most of the planets that will ever exist don't exist yet. We may not have arrived late to an empty party. We may have shown up before it started. Maybe Earth is rare, not life. Life might be everywhere, as slime. But the exact combination that got us here, a steady star, a big steadying moon, moving continents, microbes on 1 billion worlds, animals on almost none. Or maybe, and this is the one that unsettles me, everyone is simply quiet. We've been leaking radio into space for about a century, mostly by accident. But we're getting quieter. Signals are moving to cables, to tight beams, to low-power digital that looks like noise unless you're standing in it. A civilization like ours is loud for maybe 100 years. Then it turns itself down. If that's normal, the galaxy could be full of neighbors, all of them, right now, wondering where everybody is. 2 more you'll hear, and I'll be straight about both. The zoo hypothesis, they know, and they're leaving us alone. It explains every possible observation, so it predicts nothing, so we can never test it. That's a story, not science. And the dark forest, everyone hides, because announcing yourself is suicide. That one comes from a novel. Brilliant fiction, not a finding. So here's the part almost nobody says out loud. We talk about the silence of the universe as if we ran an experiment and got a result. Look at what the experiment actually was. 1960. A young Frank Drake pointed an 85-foot dish at 2 nearby stars for a few weeks on one frequency. That was the first search in human history. Since then, a handful of telescopes, mostly borrowed, usually part-time. In 1993, Congress cancelled NASA's search program about a year after it began. The work has survived on private money ever since. That's it. That's the whole effort. And in 2010, astronomers led by Jill Tarter measured it honestly. Not how many stars did we check, but how much of the real search space we'd covered, every direction, every frequency, every moment since a signal has to arrive while we happen to be listening. They worked out how much of that haystack we had actually searched. It came out to roughly 1 glass of water out of all the oceans on Earth. 1 glass out of every ocean. So when someone tells you the universe is silent, the universe isn't silent. We dipped a glass into the sea, we didn't catch a fish, and we've been explaining the emptiness of the ocean ever since. We did not run the experiment and get an answer. We haven't finished the first afternoon of it. Silence you never listened for isn't an answer. It's just silence. So, pull back, away from the telescopes, away from the arguments, out past the planets, past the sun, until our whole solar system is a speck against a wash of a few 100 billion stars. And in all of that, find the one warm point we know for certain has anyone on it. It's this one. It's under your feet. Beside it, in the dark, there's a shape we keep drawing and have never filled in. Someone else. Somewhere. Maybe. We don't know if that shape is empty because there's nobody there, or because we've been listening for less than a single human lifetime, with a handful of instruments, for a signal whose shape we're still guessing at. That's not a sad answer. It's an unfinished one. And unfinished is the best thing a question can be. We are not the ones being ignored. We're the ones who just learned how to listen. Though there's one possibility we skipped. We've been searching the sky this whole time for something out there. What if we already share this planet with life that started separately? Life so unlike us that every instrument we own is built to look straight through it. Would we even notice?